This recording is to help you remember the theorems that we've learned in the circle unit. One of the first ones that we learned was about chords in a circle. So here we learned that the product of the portions of the segment equal each other. So in this figure, W times X equals Y times Z. As far as the angles go, here's angle 1. You can find angle 1 by taking 1/2 of the sum of the measure of arc A plus arc B. Now in this figure, these were the right angles of a circle. This line is tangent because it only touches the circle in one place. We also know that it's perpendicular to the diameter. Now if you have a diameter that's perpendicular to a chord in the circle, we know that it bisects it. And in addition to that, it bisects the arc that is intercepted. Don't forget that you can also use a radius here to create right triangles. This helps you sometimes when you're trying to find the length of certain segments of a chord. With these problems, we have tangents and we have secants. Remember, a secant intersects a circle in two places where a tangent only one. As far as the chord lengths go, you have the outside times the whole. So here the outside is Y, the whole is Y plus Z. That equals the outside times the whole, which is just W times W, or W squared. Over here, if we look at the lengths of the chord, notice that you have the outside times the whole, which is just Y squared, Y times Y. And then the outside times the whole here would be W squared, but you could take the square root of both sides and simplify that with just Y equals W. Here, the outside times the whole is going to be Y and then Y plus Z equals the outside times the whole, which is W times W plus X. Now, if we go back and look at the angle measures for these, you'll see that the measure of angle 1 equals 1/2 the difference of the big arc minus the little arc. So here's the big one, and then here's the little portion. Here, the measure of angle 1 is again 1/2. Oops, forgot my 1/2. The big arc minus the little one. So it's the same exact rule for each one. So 1/2, angle 1 equals 1/2 the difference of the big arc minus the little arc. Then this one is an inscribed angle. So we have angle 1 equals 1/2 A. Now notice if you had a diameter and you have an inscribed angle, we know that the intercepted arc is a semicircle, so this is 180 degrees. So that would mean that that inscribed angle is a 90-degree angle. So any inscribed angle with a semicircle is a 90-degree angle. Area of a circle, pi r squared. If we have the sector, so we just want this portion of the circle, we take that portion that we have. So we have, if this was 60 degrees, and it would be 60 out of the 360 in a circle, and we multiply that times the whole circle to take that portion. Here we're looking at the circumference, so the circumference equals 2 pi r. If we want only a portion or the length of that arc, we would have to just take that portion of it, very similar to the one over there with the sector. So we're taking what portion of the circle do we have and multiplying that times the circumference. For the radius of a circle, you know it's the same all the way around. And if we know the center of the circle, we can write the equation of a circle. So x minus h squared plus y minus k squared equals r squared. This resembles the distance formula because really it's the distance from the center to any point on the circle. So again, the h, notice, is the h coordinate of the center. The k is the y coordinate of the center. The r is the radius. Remember to square it when you're writing these equations. And the next section will be on always, sometimes, never.